Hi, Space Village. Today we'll be talking about duty cycles. And this is an approximation of how do you look into a task and calculate what is needed to do, and specifically what is the job to be done, and what are the needs of maintenance, stoppage, refueling, anything that allows you to continue that task. Because to be fair, even with a lot of robotization and automation, you still need to maintain either those bots or any of other equipments or process automations. So we'll be looking at I'm going to call it a very fun example that is a plant on the moon. And I'll be bringing it up. So this is from Robert Bigelow's, okay? It doesn't exist yet, it might exist. But what I want you guys to look into is to the following. Top left, we have a charging station. And then more to the right, let's say this is the place where the rover or our tool machine conducts its duty. It could be picking up rocks, it could be picking up regolith. Let's say that it's that, okay? So the regolith is picked up here on the top right corner. It needs to be moved from that spot onto the station that will treat it in an appropriate way, and then being moved from that location back to the main station where, for example, other materials would be changed. Now, you understand that working on the moon with the temperature ranges, it's tough. So there is power requirements. What that means is that we need to understand what's the speed and what's the load in each one of the red segments. Really important. After this work is done, you have an option. Of course, you can move from, I'm going to say, the station back to work, or as you can see it in here, it's going back to the charging station. Where you see another one is doing the same job and they're getting charged. So what this allows us to see is that for every task, we need to also to understand in the process that it describes or the concept of operations, we also need to describe what are the charging needs and what are the maintenance needs. In this case, it will be performed at the main location. To look into how is the duty cycle. And remember, we were looking at this from a very 2D perspective. If we think that, for example, I'm bringing a case in here for an electrical tool, an electrical vehicle that picks up a bucket, and it does need to drive up, empties the bucket, drives up, displaces the load, dumps it, and then needs to drive down. So again, when you add the complexity of the slope and the type of terrain that you are working on, more needs appear in your calculation of the duty cycle. The magic number appears to be something between you do 60% of work and you do 40% of charging, maintenance, repairs, anything that has to do with maintaining the health of the cycle. So again, if you go back to our moon place, I'd like to think of this way. The left side from the main station to the charging and something happening in the main station has all to do with repairs, configurations, reviews, and the charging is like the warm-up joke on making things work, okay? And then from there, moving to the location could be another. The other arrows at the location, where in this case is picking up regolith or picking up or changing the landscape and then bringing that load into another place and then getting back to be assisted, it's essentially its duty. A lot to think, correct? When you start looking into the operations and say, okay, it needs to move from here, there, what's the slope, what's the environmental needs? Same thing. So when you build a process, we need to build the layers for each thing. What is the environment? what are the systems, what are the needs, what are the skills needed. So this, I think it's a good representation of the complexity when you start diving into inside something. And it also tells you to, if this is very harsh, take some time to recover. Enjoy the day.